press the bell icon on the YouTube app and never miss another update.
Hi students, today I am starting the new chapter of second PUC atomic structure or structure of atom. In this chapter we are going to deal with different atomic models where it explains the distribution of electrons and positive charges in the atom and connected properties. So the three different models starting from J.J. Thomson, Rutherford and Bohr's atom model. In detail Bohr's atom model we discuss. I hope you are also studied in first PUC in chemistry. Only 30% may be some new things we are finding in this chapter. And finally, about the spectral series of hydrogen atom and explanation given by de Broglie on postulates of the Bohr's theory. This is a brief introduction to that. But as for board exam concerned, it is having weightage of 5 marks. In the board paper, either the problem or the theory may ask for 5 marks. If they ask the problem, that is numerical problem, then you are not getting the theory. Or if they ask the 5 marks theory, you cannot get the 5 mark problem. If both are not given, you will find the question on this chapter, small questions like 3 to 1, either 3 marks, 2 marks, in 1 mark you are finding. But how scatters is not definite. But you have to concentrate on all 1, 2, 3, 5 and numerical section. But as per entrance, if you think, including national papers, JEE and NEET, and even Karnataka entrance, 1 question is sure from this part. In the beginning few videos, we go through the board exam paper, and finally we enter to the entrance related concept of this chapter. So, however, when we go back to 18th century, that is around 1803, Sir John Dalton proposed that every element is made of small elementary particle, smallest particle called as atom. The name was put forth by Dalton, the smallest elementary particle, which cannot be thought of smaller than this. It is when you have a big matter or element, it's the smallest part of this, smallest in size and not divisible, indivisible. It cannot be divided at all. Further division of that particle is impossible. According to Dalton, I am saying it is in 18th century. And it is the smallest in size. We cannot think smaller size of that, smaller than that size. And it is the representative particle of the element to which it belongs to. I hope you are understood. Representative particle means it represents the element to which it belongs to. If you are studying atom, you are understanding the element to which this belongs to. So if it is indivisible, further cannot be divided, smallest of smallest in size and representing the element, that particle which is smallest in size, indivisible and representative particle is called as an atom. This was the beginning by Dalton thinking about the microscopic level of matter. Later, keeping in mind this atomic concept, Michael Faraday around 1850, by his experiments on electrolysis and also discharge of electricity through the gases, showed to the world that atom consists of 2 kinds of charges, negative and positive charges. Or atom associate with positive and negative charges, still atom is electrically neutral. That means number of positive charges and negative charges must be the same, so that atom remains electrically neutral. And further, as the days passed, J.J. Thomson, the major work regarding atom started by him, that he found negative charge particle in the atom electron. J.J. Thomson discovered the electron and also estimated the specific charge of electron. Specific charge of electron as 1.7 into 10 power 11 coulomb per kg. This is the charge to mass ratio of the electron. He did two work. After discovering, he wanted to know the mass and charge that is possessing, and one experiment he conducted and come to know the specific charge. But along with him, Dalton worked. You may be heard about the Dalton's oil experiment. By his experiments, Millikan's oil drop experiment, Millikan joined his hands to him and again showed the charge of an electron calculated by Millikan oil drop experiment. The charge on the electron is minus 1.6 into 10 power minus 19 coulomb, and mass of the electron along with that he calculated as 9.1 into 10 power minus 31 kg. Fine, we come to know there is a fundamental particle called electron which disproved the Dalton's concept that atom is not divisible. But now come to know there are two particles, positive and negative charged particles. And negative charged particle found the charge of this value and mass of this. Again, the hydrogen atom, when you think there is one positive charge and one negative charge, the positive charge is having equal value that of the electron. Laterly, you come to know from the concepts and also discovered the proton which is equal to that of the positive charge and mass equal to around 1.6 into 10 power minus 27 kg, but not at this stage. However, you are knowing, you studied in chemistry detail in the first PUC about the Bohr's hydrogen atom model, where you studied about the presence of electrons going around the nucleus, and inside the nucleus there are protons, and again spectral series of hydrogen atoms and merits and demerits. Let me go details in the future videos, but I am saying that here positive charge which we are saying is proton is heaviest, and one conclusion brought at that time, they are not knowing proton not discovered also, but the concept was clear for them. Atom has certain mass and carrying some charge. Even if you take the hydrogen atom, one electron and one proton you are having. The one electron having negligible mass compared to the mass of hydrogen atom, which cleared almost mass of the atom is with the positive charge. This was the result by these experiments cleared. Because this chapter, the physics says, what you learnt about atom, how this concluded, how these results were brought out. That is the importance of this chapter of atom model. So therefore, what come to know here is from these experiments, one thing clear, mass of the atom is almost with the positive charge. Negligible mass with the negative charge called electron. Then, so all these discoveries during that period from 1800 to almost we reach 1900, in 100 years of journey, in science, major discoveries coming at the microscopic level, understanding matter in the microscopic level was started. This revolutionary changes in understanding the physical world by the man open up the new branch in physics, which we are calling it as a modern physics. Modern physics, where we majorly discuss about the atoms and nucleus. Atom and nucleus, major developments or discoveries if you want to see. Electromagnetic waves, electromagnetic theory of light, photoelectric effect, Compton effect, scattering of X-ray by the atomic particles, and even discovery of X-rays, gamma rays, and radioactivity, about nucleus, size, shape and properties like fission, fusion. Now 80% of the electrical power supply we are getting across the world by nuclear fission. The new recent researches are emerging out. Cold fission is possible. If it comes out as a successful, then it replaces the fission because it is more cheaper than fission process. So new 21st century's nuclear source of energy may come. So these are all under this, and even discovery of protons, neutrons, neutrinos, mesons, many elementary particles. The field now become very big. But we are not going to see all those in this chapter. Only in this chapter we concentrate on atomic models. Once the word I use atomic model, you may be asking what this model means. This is theoretical explanation of the atomic structure. Structure of atom is called atomic model, atom model. Theoretical explanation of the atomic structure is called atom model. What the atom model explains, theoretical explanation means what? That is what I at the beginning told. It is just understanding or explaining the arrangement of the two particles, now negative and positive charges, and each model what we take here to explain, 3 points should be kept in mind. Any model it may be, it has to satisfy satisfactory explanation by any proposed model should come. That is one about electrical neutrality of the atom. Electrical neutrality of atom. The second one is about the stability of atom. And third one is about the origin of spectral lines. So when I say electrical neutrality, atom is electrically neutral. There may be positive and negative charges. So positive and negative charges within nucleus may be intact, equal in number. Electrical neutral has to obtain means with respect to time and with respect to changing condition with environment, surrounding, it should not change its value. Electrical neutrality should continue as we are seeing in the atom. The model should support for that, and it should explain why electrical neutrality, how electrical neutrality will continue in the model. By placing the electrons and positive charges in such a fashion, it should hold them together. Negative charges should be with positive charges. On their own cannot go out of the atom, so that atom should remain electrically neutral. The second, stability of atom. Because electrons may collide with the positive charges or they may with negative charges, then that may be collapsing of the atom take place. Stability means with respect to the surrounding conditions, with respect to time, the stability, shape and size of the atom should not change on its own. Should not change on its own, the shape and size given to that. And origin of spectral lines. When I am talking about this origin of spectral lines, you have learned something in the electromagnetic spectrum. That also you have studied in the first year PUC in chemistry about the spectral series of hydrogen atom, where electrons from various orbits return to the lower orbits. Different spectral series, you got Lyman, Balmer and all. In general, when I talk, it is the ground state and maybe the level number 2 excited state, 3, 4 like that. So whenever the electrons return from higher energy to the lower energy level, higher energy to lower energy level, these are the lower energy level. These are the higher energy levels for compared to this. Maybe return to the ground or intermediate. The question is this: radiation emits, the difference of energy of the electron orbits emit in the radiation of specific wavelength. The wavelength that was observed for the hydrogen, you are also studied in the Balmer series. There are 4 spectral lines in the visible region. In the Balmer's H alpha, H beta, H gamma and H delta, you have taken it as 4 distinct spectral lines called line spectra, which is the characteristic of the atom. This explanation was given in the electromagnetic spectrum theory. Atomic spectra, it is also called, it is the fingerprint of the atom. The spectral lines must be distinct and sharp. These spectral lines should be correctly explained by the model. and atom must be stable. On its own, it should not collapse or changes in shape and size. And electrical neutrality, on its own, it should not lose the electrons or gain the electrons, so that it should continue with the electrical neutrality. Shape and size must be stable, and the spectra that is coming, at least for hydrogen atom, what we are discussing in this chapter, these things must hold good. Keeping in this mind, the first person or the scientist who thought about the shape of atom was J.J. Thomson. That you are even high school you studied, and even in the first PUC when they begin this chapter in chemistry may be explained to you about the J.J. Thomson. Here also, even it is not in the board paper, I am just giving a hint what the J.J. Thomson model is and coming back to the next model afterwards. J.J. Thomson model. It was the first atom model proposed in 1898 by J.J. Thomson. Already the three factors come to know that entire charge, positive charge and mass with atom. Electrons are negligibly size and negligible in mass also. So keeping in this mind, actually in his mind, three proposals were there. First proposal was that if just like you are learned about now, you are knowing about the electric dipole, positive and negative charges. He may be thought inside the atom, positive and negative charges may be together and made the atom electrically neutral within the atomic dimension. It was his first proposal. And second, he thought, as like the Rutherford model, there may be some positive center surrounding that electrons are distributed, maybe moving in circular orbits. This was the second thought, first proposal. In the third proposal, he took that one as the right one. He rejected these two. Why, it is not clear, but however, he rejected these two models and taken the final one. They are not, electron and positive charges are not in pair. No support may be obtained for him to explain those. Therefore, he rejected that. And also taking the positive charge at the center and electron going round came in his mind, but not appreciably taken that one. And finally, he come to the conclusion to explain that atom is spherical in shape. This gives the most stability to the atom because, you know, out of the shapes available, minimum surface area is for the sphere. Minimum area, why we are taking? Because exchange of energy, radiant energy possible through the surface. If surface area is minimum, exchange of energy is minimum, that supports the stability of the atom. Therefore, he was taken, and also thinking about the kinetic theory of gases, Avogadro numbers, taking unit volume, number of atoms possible, and what is the size of atom. Correctly, he come to the conclusion, the size of the atom is around 10 power minus 10 meter or approximately 1 angstrom. And entire volume of this sphere is with positive charge. Is a positively charged sphere called as. It is taken as a positively charged sphere. How the electrons are, it must be electrically neutral. However, they are very negligible in size. Therefore, he thought of that the electrons are arranged here and there. They are embedded inside the sphere, positive sphere. So that was not clear explanation, but their electrostatic force of repulsion between the electrons may be compensated with this positive sphere inside. Thereby, electrons are stable inside that sphere. And he compared with a watermelon. When you cut a watermelon and see that the reddish part, fruity part of the watermelon is a positive charge. And seeds of the watermelon we are seeing that spread inside it. Like electrons also spread inside, stable in it. That was the second postulate of him. He was taken this as the right one. Atom is spherical in shape. Size is around 1 angstrom. entire sphere, volume of the sphere is with positive charge, as like in watermelon we are seeing the fruity part reddish color, and as like seeds are distributed in watermelon, the electrons may be distributed in it. So you know watermelon mass, fruity part mass and seeds mass. So he compared with that one, and to explain this stability may be good, because I told you spherical shape and size good, agreeable, they are the merits of that J.J. Thomson model. Electrical neutrality is right, because electrons are inside it and total positive charge may be balanced but not clearly explained. But how the spectra will come, he told that whenever we supply energy to the atom, the electrons of this atom will be perturbed. They start vibrating. These vibrations, because you know electromagnetic theory, accelerating charge produce electromagnetic waves. Thereby this energy radiation comes. But it can vibrate with all possible frequency. That means it can emit all possible wavelengths. That are the three major postulates taken in the Thomson atom model. Atom is spherical in shape, size is about this, entire volume is positively charged, second postulate, and electrons are embedded in it here and there, so that the electrical neutrality should be maintained. Third, when slight energy given, electrons of the atom may be disturbed, vibrate and radiate energy. And this radiate energy may be have all frequencies, because there is a classical theoresis, even electromagnetic classical theory gives you that all possible vibrations may be permitted for the electrons inside the atom, and these vibrations leads to the radiation emitting by that atom, and all possible vibrations radiation comes. By this, when you think what are the merits regarding this, that is why I told structure of atom is distribution of electron and positive charges. What are the merits of this atom model is, number one, stability concern, that is size and shape. Till today we agree spherical shape. Size of atom is also estimated to be right. Till today, you know, size of the atom is around 1 angstrom. That is the merit of this atom model, first atom model proposed by him. The second, stability as such is good, but third is wrong, because already I told you in the hydrogen spectra you got the different spectral lines, discrete, possible when the electrons vibrate with a specific frequency and emit a specific wavelength radiation. This cannot be possible by this model. The origin of spectral lines is not explained correctly. And another drawback is the fourth one. That is what we are going to see here, the alpha ray scattering. He could not explain the alpha ray scattering experiment correctly. So it does not support the origin of spectral lines correctly. In brief, I can say the limitations of this is alpha ray scattering experiment. Alpha ray scattering, how exactly take place is not explainable by this. If you take this model, alpha ray scattering happens to be the wrong one. So then origin of spectra is not supporting for that. Therefore, the two major demerits. Major merits are shape and size are good, stability is good. Demerits are two. One, it could not explain the origin of spectral lines correctly, and it could not explain the alpha ray scattering by the atom. So this correction to apply, because the student Rutherford was the student of the Thomson, and student of the Thomson are the Giger and Marsden. This alpha ray scattering experiment is the base to understand the structure of atom. Most successful, and how the nucleus concept is brought by this. Task was taken by Rutherford and given to his students Giger and Marsden. So what we are seeing in this is in your syllabus. What I so far told you is only to enter into the topic. An introductory part starting from what atom is, When we say which one is called as a atom model, any theoretical explanation of the structure of atom is called atom model. That should explain the three important characters: electrical neutrality and stability of atom and origin of spectral lines. These should be, every atom model should give explanation correctly or satisfactorily. However, coming to this is the beginning of this chapter. The important one, Giger-Marsden experiment. The students of the Rutherford who proposed the second atom model, we are calling it as a nuclear atom model. However, in this experiment, what are the content and what exactly it reveals, how it supports the exact atomic nature. So this is a lead block in which we kept the radioactive material which is emitting alpha particles continuously with the energy of about 5.5 mega electron volt. We selected this because that much of energy is necessary to get the scattering properly through the gold foil. So that energetic alpha ray is emitting by bismuth 83-241, kept in the block, continuously emits, and they may be scattering here, they spread off, diverging beam of alpha rays are coming out. Lead bulk is a good absorber of the alpha rays. So therefore, alpha rays means it is helium nucleus. Helium nucleus is called as a alpha ray. That means it has charge 2e and mass 4p, 4 times the mass of proton. So now coming to these alpha particles, when they scatter in different directions, they may be gets absorbed. That is what, by using these lead bricks. Lead bricks, we collimate the beam. We are converting into a fine pencil of ray. After passing through the bricks with a small slit opening, so these alpha rays are made to strike the thin gold foil. You may be thinking, why we selected the gold foil? It has high ductility. Ductility is very high because of that reason. That means it can be drawn into thin sheet, ductile property. Drawn into thin sheet so that it is very thin. Very thin, you can think, bringing thinner and thinner, it cannot break down. It cannot rupture. That is why we taken gold foil, and it is also, its atomic number is 79. Heavy element, but not breakable. When you taken to the size of atom, that means almost 10 power minus 7 meter. I think why? Because we have to scatter the alpha particle. We have to pass the alpha particle through the atomic dimension. Suppose this is the thickness of the gold foil, earlier maybe. When you are thinning it by compressing or cutting this, made thinner and thinner and such a thin, this made thin plate. There is no two layers of atoms. It may be single layer in which the atom is present. Like this, we made a layer, there is an atom. This is the atomic layer. So thin made, possible because of the ductile property. So therefore, it can be drawn into thickness of almost 2.1 into 10 power minus 7 meter, that in this plane there is one layer of atoms. One layer of atoms, so thin it is. That made the alpha particles to pass through the atom. This picture I am showing, little bit you think about that. Here, perpendicular to the board. And again, these rays which are passing through the gold foil, this is the gold film. And these alpha rays, after passing through that, we say scattered in different direction. And they are made to fall on a circular luminescent surface, screen, zinc sulfide. When the alpha rays fall on the zinc sulfide, we eliminate the surface. Luminescence is appearing. Each alpha rays, when strikes, gives the light. Fluorescence property. That was detected by a detector with a microscope. Counts. Every alpha particle may be counted by this luminescence property in very short time, fraction of second. That is a detector which counts the number of alpha particles receiving on this detector every time. And it is possible to move along this circular track round this. At the center of the circular track of the screen, we placed the gold film. And we are going to learn. And this setup is in the vacuum chamber, because if air particles that may get ionized by the striking with alpha particles, and our experiment gives some other results. To avoid that, complete setup is in the vacuum chamber. This is the experimental setup. If they ask the experimental setup, we have to draw this figure with labeling what we have did here. Is a lead block which may containing the radioactive material bismuth 83241, which gives the alpha rays of energy 5.5 MeV, mega electron volt. These diverging beams of alpha rays are made highly collimated by passing through the lead bricks. The diverged alpha rays gets absorbed, only one line, fine pencil of line is admitted and made to fall on a thin gold foil, whose atomic number is 79 and thickness of the gold foil is almost the size of atom. That means one layer of atom we are placing here, think of that. All scattered alpha particles are passing through after passing through the gold film are made to strike on a screen made of ZNS, zinc sulfide, which illuminates, which shines because of fluorescence property that can be detected by using the microscope. This is an arrangement, we are seeing it. So what happens, let us see in the experiment. We come to know the arrangement only. Theta versus number of this, maybe 10 power 7, 10 power 6, 10 power 5, 10 power 2, 10 power 1, 0, 10, 20, 40, 80, 120, like that. Now you come to know the Giger-Marsden's experimental arrangement. How this explains the structure of atom, let us come to. However, we are admitted the alpha rays originated from the bismuth radioactive element, highly collimated with this much of energy, made to fall on the gold film. What observation made is, if you take the first observation, number 1. First observation, if you keep the detector here and observed counting is done, if you made 1000 alpha particles to fall on the gold film, out of 999 will reach the detector without much deviation. Most of the alpha particles passed through gold film undeviated. They are not deviated at all. Most of them is traveled straight, which are incident on them. I thrown 1000 in this area. This is the atomic size, imagine, about 10 power minus 10 meter. 1000 alpha particles strike in this region. All the alpha particles are striking in the atomic dimensions, passed undeviated. Most of them, just one out of 1001. There is a small angle of scattering theta, maybe showing greater than 1 degree, 1 in 1000. Second, 1 in 1000 shows small angles of scattering. Some of them may go, if I brought here, so suppose I am slowly bringing this side. As I am coming like this, as theta I am increasing here, detector is either it can move like this or towards this. When I come to this line, this become 90 degree. And very few observed showing theta greater than 90 degree. Some, very few of them, this angle become more than 90 degree we are seeing here. very less. And even when you come to here, detector when I brought to this position, almost gets returned. It is 180 degree. Theta is 180 degree. Not exactly, maybe 179 like that, 79, 78. So the gets returned. That means if you see the fourth, 1 in 8,000 shows theta is almost equal to 180 degree. That is scattered back in the incident direction. Almost 8,000 or around 10,000 when I showered on the atom dimension. Returning is only 1. And you are seeing that here, as you go, the scattering number goes on decreases, and here very less. But here there is very large number of alpha rays we observed in this region. But there is very less number of alpha rays are coming in this direction, or it may be returned like this here. So these are the observations made. Why it happens, let us discuss further. And also we seen that number of alpha particles that is cleared, theta is 0. Theta is 0, very less number. As theta is goes on increases, at 180, number of atoms is negligible. Number of atoms negligible, it is n0 atoms, then striking, I am saying striking number. If we are giving that, almost scattered out, and then this become almost 0. When theta go to 180, almost 0, less it is maybe 1 atom. You are getting back. That means, so the number of scattered alpha particles, number of scattered alpha particle is found to be inversely proportional to sine to the power of 4 theta by 2, where theta is the scattering angle. Theta 0 means it is almost infinite, that almost all the atoms, infinite means almost all the alpha particles striking may pass through that and given that result. So why this happens so then? So the first explanation, if you take on the first one, almost all the alpha particles which are incident on the dimension of the atom, out of if example taken 1 in 1,000, almost all are passing with 1 or 2 is getting reflected back, which suggests inside the atom there is a large empty space. Why? Why you are thinking so? The question arises. Suppose if you think like Thomson, J.J. Thomson, if the charge is uniformly distributed in the atomic dimension positive charge, my answer is every alpha particle striking at different positions of this, what you can think is they uniformly should scatter. There is no different angle of scattering and different numbers we see. So why that is happening so? Because charge is not uniformly distributed, positive charge is not uniformly distributed. Why it is thinking so? You know, suppose this is a positive sphere, has some charge Ze, and alpha particles have charge 2e. It is Z is 79e, imagine 79, gold fine. 79e, it is 2e. What is the electrostatic force of repulsion between them is Q1 Q2 by K Q1 Q2 by R square. As it comes closer and closer to the nucleus or atom, there is a repulsion. Large repulsion should take place because repulsive force will not allow the alpha particle to come closer to the atom. But we are seeing a different scene. How this is, I will take up in the other. So understand that phenomenon. What I say is here most of the alpha particles go straight and we say according to the first observations there is a large empty space, electron and alpha particle attraction is very less because mass of electron is negligible, its role in the scattering of alpha particles is negligible. But only with the positive charge we are thinking there is a repulsive force according to Coulomb's law of electrostatic. If the atom is entirely positive charged, if an atom is entirely positive charged, then uniform scattering has to come, it is not coming, therefore we rejected the Thomson thought. But how to conclude, what conclusion we draw from this large number of alpha rays which are passing through that atomic dimension without deviation, means there is an empty space, means there is no positive charge at all. For this to understand, we are using a word called impact parameter. Impact parameter, suppose this is the point we are thinking something where there is a strong repulsive force, entire atom is not showing the strong repulsive force. If it is the atomic dimension, taken, so this is the portion where positive charge we are expecting. In the entire other part, this is almost empty. For example, if an alpha particle enter from larger distance from this part, a peripheral region of the atom when enters, it goes almost straight and then gets repelled. Why gets repelled? Because there is a distance from the center of this atom to the velocity vector of the alpha particle. Alpha particle have 2e charge, where it is have ze charge. So this is the direction, there is a scattering angle we got here, but it is delayed scattering is observed and less. But if I bring another alpha particle which may be closer compared to the earlier, it is earlierly get scattered. So still closer, if you brought another one, it can be brought like here. And still almost it is head on, it cannot reach, before that it gets returned. That is what we observe here. This is not collision, means head on collision here. There is a electrostatic repulsion. I taken this force of repulsion is K Q1 Q2 by R square, where R is this distance. When the distance between the alpha ray and the center of the atom become larger and larger, scattering angle decreases. But when the distance goes on decreases, scattering angle increases here. So here it may be around reaching 90, it is becoming more than 90, it is becoming 180 degree here, theta. This is called as the impact parameter. Impact parameter, what is the impact parameter? Means perpendicular distance of the velocity vector of the alpha particle. See this, conceptually understand correctly, velocity vector of the alpha particle with the center of the atom. Center of atom to the velocity vector of alpha particle, the perpendicular distance is called the impact parameter. It gives a very good clue for us. If we calculate it, it is found to be Ze square into cot theta by 2 divided by 4 pi epsilon naught into E is the energy of the alpha particles. Energy of alpha particles, theta is the scattering angle, Ze is this, and 2E is that value. So this is expression for the alpha ray impact parameter. You come to know that theta increases, beta decreases. That means when the alpha ray come closer and closer to the central pole, repulsive force is increasing. Electrostatic repulsion is increasing because it is a strong positive center, if found to be. If it is not distributed in the entire volume of the atom, if it is concentrated in smaller and smaller region, that clue why comes because I told you in the fourth observation 1 in 8,000 gets scattered by 180 degree. That means if you approximated 1 in 10,000, the size decreases to that much of time. 10 power minus 10 to go to 10 power minus 14 meter, 10 power 4 decreases. Size of the atom as a whole is 10 power minus 10 meter. But I am going to the size of 10 power minus 14 meter when reduced to. This suggests highest scattering is observed, large angle scattering is observed, almost alpha particle is scattered back. Where? In a very small region. That means 1 in 10,000 length, 1 in 10,000 size reduce. That is about 10 power minus 4 meter. Thinking there is a scattering possible means in that region of small region there is a large strength of repulsion possible, implies mass and charge of the atom is completely in that small region. 99.9% of the mass and the entire positive charge only with that small region can give this result of large angle scattering of alpha particles. Electrostatic force is so strong, it is having highest strength, it is a center of the atom having highest strength of positive charge and mass it carries because momentum is also strong, which can powerfully reflect the, set back the alpha particle entering into it without disturbance. But as you move away, Bose decreases suggest it is not present at all, which made Rutherford to conclude that atom consists of, in a small region to the order of 10 power minus 14 meter size, radius of the nucleus. This strength, highest positive strength and almost mass of the atom containing region, Rutherford named it as a nucleus. Thereby he proposed nuclear atom model. That is later. But I am saying why the large angle scattering made possible only concludes that positive charge and mass of the atom is not with the entire size of the atom, it only with a small space. That space is around this much. So that is why as you go outer and outer, the theta goes on, decreases, impact parameter increases. Impact parameter, collision impact. Collision impact is highest, that become 180 when B is 0. That means the size coming to this order. That is the first conclusion, that empty space. The first one I told, most of the alpha particles which are incident on the atomic dimension passed through that directly without much deviation. Very few shows small angle scattering and almost 10,001 alpha particle can give large angle scattering more than 90 degree or almost 180 degree, which concluded that there is empty space in the atom first. Large empty space, entire positive charge and mass is crushed into small region, highest strong region which you are knowing possessing with the strong nuclear force. Strong nuclear force which is charge independent, you studied first year also, fundamental forces. Strong nuclear force which is charge independent. And it is short range, within that 10 power minus 14 meter dimension it is operative, not outside it all. So therefore this with a strong force, they are present and they repelling any particle outside with that strength. Thereby nuclear concept was brought. And he was stated how the electrons are in the atomic dimension means electrons go around the nucleus in circular orbits. Circular orbits, as like we are seeing the planets go around the sun. He compared the planetary model to the atom. Electrons are planets and sun is the nucleus. Round the sun how the planets go round, similarly the electrons go round the nucleus in orbits within atomic dimension. That's one we coming to know. This number of scattering of alpha particles depends on this scattering angle sin power 4 theta by 2. Also depends on energy square. the incident alpha ray particles energy. If it is kinetic energy, you know, half m square, inversely proportional to e to the power of 4. As for entrance importance, it necessary. If you are increase the energy of the alpha particle, what happens to the number of particle scattering? And similarly, if you go towards the Z, that is the nucleus you have taken. Here we have taken the 79 gold. If higher the Z value, n is increases. And then coming to the thickness, larger the thickness increases. So these are dependent factors of the scattering angle. And you come to know impact parameter, one thing, where higher the B value, definition sometimes asking you in the board exam, define impact parameter means it is the perpendicular distance between the velocity vector of the incident alpha particle to the center of the atom. We call it as impact parameter, and here the expression for it. And another important in this is the distance of closest approach. Distance of closest approach. Now we are seeing here. This is R0, center of nucleus. When I given an alpha particle, I give separately here. I will take up that separately. So this is the now already come to know it is a nucleus having charge Ze, and it is the atom. An alpha particle having charge 2e and kinetic energy E. Is made to strike. As it is approaches, there is a repulsion from the nucleus at some position. When it reaches to this position, there is a potential energy of this nucleus. At this point, potential energy of the nucleus becomes equal to the kinetic energy of the incoming alpha particle. Then it will stop and gets returned back. The maximum distance up to which it can reach is called as this is the minimum separation between the nuclear center to the nuclear center at the bottom. Nuclear center to this is called as the distance of closest approach. Minimum separation between the nucleus to the scattering back point. Minimum separation to this point of scattering back and this distance. You can get this R0 value. R0 value, you know, it is energy given here in terms of maybe mega electron volts. Potential energy is Ze divided by 4 pi epsilon naught into R0 is the potential at this point due to this charge. Nuclear charge produce electric potential at a distance R0. Now at this point, its kinetic energy has to become means when alpha particle is placed here, that is minus 2e. I take only the magnitude, so therefore I use a plus here. So this E, the total energy becomes 0 and compensating become plus 2e. Now if you want R0, the expression is 2 into Ze square by 4 pi epsilon naught into E. This is the expression for closest approach. Minimum separation between the point P, returning point to the nucleus. This can depend upon the energy. Higher the energy, you are given larger energy to this alpha particle, you are expecting R0 goes on decreases. R0 decreases with increase of E. R0 is proportional to 1 by E. But this gives us the size of nucleus also. That is why taken here correctly. What happens if you are going on increasing the energy of the nucleus, alpha particle? As you are increasing the energy of alpha particle, R0 goes on decreases. It is coming closer and closer and closer. If you increase further, it coming still closer. If you increase, it may come still closer. If you further increase, it may come still closer and cannot return at all. It will be gets absorbed by the nucleus, where the electrostatic force of repulsion become negligible and strong nuclear force become dominant and get absorbed that alpha particle. That happens when it reaches the size of nucleus. This is the hint how the Rutherford thought the exact size may be to the order of 10 power minus 14. Because you are knowing this energy, you go on increasing slowly the energy given to the alpha particle. R0 is decreasing slowly and it is approaching towards the nucleus possible at one particular energy. That is the maximum energy that an alpha particle can achieve, where the alpha particle cannot scatter back. That is called as the radius of the nucleus, size of the nucleus. There he found to be to the order of 10 power minus 14 meter. These are two important here relations I shown here. One is impact parameter and other is the closest approach. Here the questions are coming more in the entrance. We discuss the question on numerical problems. But this just I concluded here. This alpha ray scattering by Giger-Marsden experimental arrangement. So it is appeared in the board exam also. Many times they ask this just to represent the experimental setup, label the parts, or sometimes they ask the what are the observations made and what are the conclusions from that. So one thing you come to know, observations, most of the alpha particle incident on the gold foil passed undeviated. Only very few, 1 in 1000 show small angle scattering. And very few will show the large angle scattering more than 90 degree. And 1 in 8000 or 1 in 10,000 will show almost the scattering by 180 degree. This is an observation just. What the conclusion? Undeviation. 99.9% of the alpha particle incident on the gold foil goes straight without deviation implies that there is a large empty space in the atom. That is the conclusion part asking us. What are the conclusions of alpha ray scattering experiment means? You have to say most of the alpha particles passed through the gold foil undeviated implies there is a large empty space. Why? We explained that one. And second and third, very few particles show some scattering of large angle more than 90. And only 1 in 8000 gives 180 degree scattering back almost, suggest that the entire positive charge and mass of the atom is concentrated in a small region called nucleus. The name is put forth by nucleus, and later on this concept he proposed the model called as the nuclear atom model, Rutherford atom model may be called as. So that is again we have taken the two concepts here, impact parameter and also the closest approach. Impact parameter I told, that is the perpendicular distance between the center of atom to the incoming velocity vector of the alpha particle. It may be scattered having some angle, and equation also given to you for that. And again closest approach, minimum separation between the nucleus to the alpha particle just return back, scatter back is nothing but R0. When it scatter back, when the potential energy of the alpha particle become equal to the supplied energy due to this nucleus, then it go back, return to backward because of strong repulsion by the nucleus. But I given you a hint how the nuclear size is brought or calculated from this alpha ray experiment. As you increase the energy of the alpha particle, the value of R0 goes on decreases. But when it is goes on decreases continuously at a particular distance, at a particular energy, when it reaches to the nucleus, you know in nucleus, strong nuclear force is stronger than electrostatic repulsive force, and that get absorbed the alpha particle rather than returning it. the reflection of the or scattering back of the alpha particle is not possible. We cannot get that alpha particle back as earlierly we are seeing. Slowly you tune and increase the energy. At particular energy, alpha particle disappear. It cannot come out because strong nuclear force gets absorbed it. Charge independent, then attractive force start rather than repulsive force. At that point, taking that value, calculate, you will get this order, which suggests there is a nucleus. In that small region, strong nuclear forces bound the positive charge and the mass of atom, and electrons go around it in circular orbits, as like the planets go around the sun. Was the thought of Rutherford, and he brought up new model which is called as the Rutherford atom model. That we can see later. I hope you have followed this. The major thrust today's class is about this Giger-Marsden experiment, observations and conclusion. Here one strong clue came from this alpha particle. Main thrust of this alpha particle, what is nothing but it brought the idea of nucleus and experimentally showed and proved that entire positive charge and mass of the atom is not distributed in the entire size, but in a very small space, and size also clearly mentioned, about 10 power minus 14 meter, less than that, all positive charge and mass present. And Rutherford named that strongest region of the atom of positive charge as a nucleus. How the electrons are to have electrical neutrality? He told electrons are go around the nucleus as like we are knowing it. But there is some problem about that we can discuss later. Yes, students, today I conclude here. In the next video, we start what is the Rutherford model on the concept of alpha ray scattering, what the postulate he brought up, and merits and demerits of the Rutherford model, and enter to the Bohr's theory. It is known theory for you. You studied in chemistry first year. It is a revision class, almost become to you. Then we enter to the numerical section. Thank you.